Hey guys, it's Jennifer from Breakthrough Maths and welcome to this video on how to deal with quadratic sequences. So we've already dealt with linear sequences. We know that linear sequences have the same first difference. What we will see about quadratic sequences is that they have the same second difference. Here we're told Orla is asked to write down a quadratic sequence. She writes down the following numbers. Exactly one of the terms is incorrect. Write down the correct quadratic sequence in the spaces below, so we're writing it down here, and you may only change one of the terms in her sequence. So one of the terms here is wrong, and we're going to have to find out which. So first of all, we'll write out all the terms. We've 5, 6, 9, 14, 22, 30, and 41. So we'll start off by finding the first difference. Okay, so the difference between 5 and 6, 6 and 9, 9 and 14, 14 and 22, 22 and 30, and 30 and 41. So the difference between 5 and 6 is 1. The difference between 6 and 9 is going to be 3. The difference between 9 and 14 is going to be 5. The difference between 14 and 22 is 8. The difference between 22 and 30 is also 8. And finally, the difference between 30 and 41 is 11. So they are our first differences there. So if this were a linear sequence, they would all be the same number. So let's say, for example, they'd all have a first difference of 3. But obviously here we can see that their first differences are different. So next we'll find the second difference. So if this is a quadratic sequence, all of the second differences should be the same. So the difference between 1 and 3 is 2. The difference between 3 and 5 is 2. The difference between 5 and 8 is 3. The difference between 8 and 8 is 0. And the difference between 8 and 11 is going to be what? That's going to be 3. Okay, so we have 2, 2, 3, 0, and 3. So we can see that this doesn't look like a quadratic sequence at the moment. But we were told one of the terms is wrong. So which ones are right? Well, we know 5, 6, and 9 all seem right because they give us a first difference of, that give us a second difference of 2, excuse me. So the second difference between 5 and 9 gives us 2, and also up to 14. So we can see the difference between 9 and 14 is 5, and then 5 minus 3 gives us the 2. So it's from the numbers onwards here that we start to have an issue. So if we need a second difference again of 2, the whole way along, what would these numbers need to be? Well, the difference between 5 and 8 is 3. If we needed a difference of 2, this number would have to be 7. If we needed another difference of 2, this number would have to be 9. And then the 11 could stay the same because the difference between 9 and 11 is 2. Okay, so what would this make this number here then? 14 plus 7. So we'd have 14 plus 7 instead of 14 plus 8, and we would get 21. Then we should have 21 plus 9. That would give us our 30, and then we'd have the 41. So all of this would work out. So just to double check, if we have 14 to 21, we know that's a difference of 7. The difference between 5 and 7 gives us that second difference of 2. The difference between 21, the number we want to go with, and 30 is going to be 9. The difference between 7 and 9 is 2, and the difference between 30 and 41 is 11, and the difference between 9 and 11 is 2. So if we're to write out our correct sequence in the box here, we'd have 5, 6, 9, 11, 4, 6, 9, 14, 21, 30, and 41.